All to another session with Aditya Mehta. We had another session sometime back. So this is going to be really great. So Aditya comes with the. We are going to talk about quantitative finance and how you can build a career in that, and we are going to delve deeper in this domain. So let me first very quickly give you some background about Aditya, and then let me invite him on stage so that you guys can connect with him, learn from him, and so on. So Aditya comes with a 12 plus years of experience in quantitative finance. He's worked with various companies. He was the ex AVP at Edelweiss. He has worked with Credit Suisse, MSCI, Bloomberg, and many more big names in the industry, and is a very fine quantitative finance expert. So today so first of all, let me just invite him. Hi Aditya, good morning.
Hi, Radhika. Good morning.
How are you?
Morning, all. I'm doing well, thank you.
Great. So, first of all, Aditya, thank you so much for taking out time on a Sunday and taking up this session for all our learners. And yeah, I think it'll be better if you can give us a little bit of a background about your self.
Sure, Radhika. So this is going to be the second session of this Quant Finance series that we are running. And just a bit of background about myself. So I have been into the quant finance industry for the past 12 plus years, working in different multinational companies in different areas of quant finance that we have discussed in the previous session as well. So, and generally very much enthusiastic about sharing my experiences about this interesting and exciting field. Uh, I have worked at Edelweiss, MSCI, Credit Suisse, Bloomberg prior to where I am currently working. And academically, I hold a master's degree in quantitative finance from Rutgers Business School and a bachelor's degree in computer engineering from Mumbai University. So, yeah, that's a bit about me.
That's awesome, and that's actually very you have a very strong experience in this field. So I think you are the best person we can learn with. Also, a lot of our learners are watching this live. So guys, you can ping us in the chat box. So when during the session also, whenever you feel that you have some doubts, keep adding comments or any whatever doubts you have, and we'll take them one by one. So Aditya, can we start with the session then?
Absolutely. Let's.
Awesome.
I'm also going to share my screen. Let me know if you're able to see the screen. Everyone, can
Yes,
you
please.
type in the chat box, please, if you're able to see?
Yeah, I think it's visible.
It's visible. Okay, got it. That's good. So, welcome all to this exciting session. So, today we are going to discuss much in detail about and really in terms of some real life examples on what is um, what does a quant analyst really do, and how exciting is the career, what are the kind of projects or what are the kind of tools and technologies that this career um, would have you work on. So we've prepared a few slides, but prior to going to these slides, I just wanted to give you a quick primer in terms of what we have discussed in the previous session. So we discussed more about the quant finance as a field, the kind of roles that one would play in that field as a quant. So starting from the developer to a quant researcher, and also there are also different industries in which a quant would really play a role. So asset management industry, buy side, sell side, algo trading, and so on and so forth, right? And also we discussed mainly about the skill set that is really required for getting into this career domain. So both in terms of hard skills, soft skills, and prospective career or employers that are there in each of these categories as cons. So that's a pretty much kind of a recap of the previous session. Feel free to um, revisit them into the YouTube videos that will be uploaded in the channel. Um, and let's go to the session, today's session, in terms of what we are going to cover. The first item is going to be the day in life of a quant. Uh, and feel free to drop a line or comment on the YouTube channel in terms of what exactly would you like to know about the day in life of a quant. We have thought about it in segregating into different facets. First, as an entry level quant, um, how does a day in life look like? And then for a little bit senior in profile, um, as a manager with maybe one or two people reporting, or maybe having to deal with multiple projects with 4+ years of experience, how does a day in life look like as a quant? So we've thought about it like this, and we're going to present it in a manner that is we've thought about that is about this thing. But feel free to drop in your comments if you like to know more in details about a particular thing for a particular quant profile. So um, let's start with the junior analyst as an entry level. So what we have is, in general, we say that day in life, there's no typical day, because it's more about, these are all quant profiles. So generally what they'll be doing is, um, some days will be spent on a single project, and that's great, because it will enable them to focus on getting the details right. But on other days, maybe the entry level quant would be working on the implementation or the discussion phase of a particular project, where we'll have meetings to discuss potential problems, what are the next steps, and so on and so forth, right? So how would a day really look like? Let's say, maybe if I were to give you some color on that, um, for the entry level quants, we expect, and I think this is from my personal experience as well. um, After this slide, we are also going to cover some real life use cases, real life projects that quants will be working on. And we have seen, for most of the organizations, these entry level quants would directly jump into direct working on those projects hands on. So and that is when we'll cover more details about those projects. But so those were it is more of the projects that will really be more important in terms of delivery. So there are deadlines. It's not like you have a fixed time to come in for the day and fixed time to leave. So generally, let's say, from my perspective, I start my day, so I work at an MNC, wherein we have to support the US hours. So we start at around 12 in the noon, India time, and then we go until 9 or 10 in the night, to have good amount of overlap with the US time zone. So um, it does not have to be like a fixed hours, um, but it needs to be having deadlines, and we need to adhere to those deadlines. So it is more about projects that one needs to be mindful of. So 90% of entry level cons would be working on projects. 10% would be daily ad hoc queries that would vary depending on the kind of quant profile you are into. Maybe it's like for developers, it would be handling some bit of production issues. For maybe a quant researchers, it would be managing stakeholders' queries with respect to some complex math um, um, understanding. So it would typically vary depending on the kind of quant profile you are into. But generally speaking, it is all projects, and less of ad hoc queries, as I would put it. And how would a typical day look like? I mean, um, when we start working, we would have to. So let's say we're talking about algo quant, for example, right? An algo quant would really start looking at um, initially. So algo quant, who are algo quant? So these are like quant developers who would be supporting trading desk to execute the trades in an automatic fashion, depending on the rules and the signals. Now, um, for developing these rules and signals, one would need to have good amount of data feeds being in place prior to taking those decisions or basically having those signals generated, right? So it typically starts with checking the emails overnight, checking the emails in the morning for the overnight jobs that were run in terms of jobs are basically automated tasks, which would really be doing downloading the financial data and uploading to our internal reports. um, so those kind of things are like pre I think pre-processing before you get started with the day. So those are kind of jobs that one would expect a junior level quant to really start working on. And particularly the interest is more towards learning the business in general. So for the entry level quant, so learning the business in general, um, and reading more about um, the business. So let's say it would be as simple as reading the Financial Times, or reading or going through mathematical or programming textbook. Um, so that's something one would really prefer over just reading through maybe some page three newspaper or something like that, right? So um, when a quant would really arrive at work, um, there would be, again, there'll be some remaining automated data tasks which we need to check if it is successfully completed. Then we need to understand if we have a big research project that is coming up, but do we have all the things lined up? And we're talking about algo trading quant, so who would need to support daily live trading activities. So um even if it is like testing scripts which is going to be pushing into the staging server. So all of those fine tunings needs to be done and checked on a regular basis. So broadly speaking, this is more from the uh, typical day perspective, but it is also from the project perspective as well. So are you so in when you are live with a trading environment, let's say you're supporting a London desk or you're supporting a New York desk, so those live hours are when you will have to be available with the trading team, supporting whatever task or whatever analysis that one would be required to do. But after that is completed, those live hours are completed, or you have some break in between, you need to think through what additional automation or new vendor check or new testing that one could do is important. So one of the things that is quite prevalent in the market is to replicate the licensed tools. Now, as you might know, the firm would be spending I think a six figures a year in terms of dollars for the licensed tools and from the other vendors, right? So specifically, the task is given to the junior quants to get used to extracting the data, do some data analysis, keep the data for modeling purposes, build a model, and giving out the signals. So can we do some rebuilding of such tool so that we could stop the license and run it ourselves? So it is basically stopping the off the shelf solution and building it in house. So which could really work wonders in terms of saving. It could do wonders in terms of providing the right growth at an initial stage to the junior quant. Um, but I think these are the opportunities where junior quants will need to be exposed to really understand the business dynamics, to apply what hard skills they have learned, and really make a meaningful difference to the firm at large. So that's how I would summarize the junior quant day in life. Um, and feel free to drop a line on YouTube channel if you need to, if I might have missed something, or if you need to know more about junior quant. Um, moving on to the next one, it is at a manager level. Um, quant. So the broad profile still remains same. It is here what is more expected out of a junior quant or a seasoned quant is going to be in terms of managing both sides. Managing down in the sense in terms of managing the work from the junior quants, uh, and providing enough guidance to them, um whether and instructions rather, to provide, to fetch the deliverables in the right quality from the team, and also managing up in terms of managing the expectations from the senior management, wherein um, new ideas or new projects would be thought about, and so good amount of work would be entailing project management, um, people management as well, along with the quant space. So good amount of academic research papers. So let's say every project would generally start off with reading a lot of academic papers, set up a plan of approach, get it validated by your respective managers, and then work in intervals to code everything, right? So you would decide, you would actually um, phase it out, and build a solution in a much more agile fashion. So this is how the projects would generally work. Um, but for the managers, it is just a bit different because they are now expected to at least have good amount of understanding about the business, and also work in a manner that is um, idea generating as well, which could help the business build more models, build more tools in the quant capacity that one is working on. So that's how I would summarize these two profiles, um, and general their uh, day at work. Um, and feel free to drop a line or drop questions if there are anything on this topic. Moving on to the next slide, we will discuss more about the real life quant use cases, um, and these are some selected use cases that will help you familiarize where this is applied, and and there could be many such use cases. So these are just like few which we have taken out here, and I wanted to broadly cover what is the thought process in each of these um, use cases that is expected out of a quant. So and what is the level of thinking that one would be really be required to work on these, and it also gives you a flavor in terms of where all what's the breadth of this quant finance space, and I think we have also categorized in terms of different categories of quants which we discussed in the previous session. So um, let's go one by one, real quick, and I will actually deep dive into some of these in a manner that I assume that the audience would have preliminary understanding about what the subject we're talking about. If one is not aware about it, feel free to Google it to understand the topic. But what is expected out of quant will be discussed in this particular session. So first things first, first is the macro level quants, wherein um, one of the key indicators at a macro level is how is the inflation, how is the consumer price index, CPI inflation faring, and what is your prediction going forward. Now, why is it important? Okay, let's understand first why is this really important. So this CPI inflation is a good data point. If I am able to forecast this inflation reasonably well, then I can basically have an advantage in the market or in the industry to to have some discretionary bets and in while I'm trading. So while I'm trading, especially in the interest rates like bonds or fixed income instruments, also it will also be applicable to broad equity markets as well. Because let's say if the inflation is going to very elevated levels, right? Let's say right now US, as we see, we have like a 40-year high inflation that has been recorded last month. So if you were to able to forecast this and forecast the regime in which it will really pan out, then you are actually giving good amount of comfort to the traders to place their bets, whether they are expecting the markets to be in a risk on or a risk off stage. So these are kind of important indicators, and and I'm just trying to give you a broad perspective here why this is important and where do the cons really fit in. So it is more about how you build the model or how you build the method to forecast these inflation. So if I'm able to build a decent enough, or decent in the sense if I'm able to build a good forecasting model to have define this inflation and publish it to my internal team or for just decision making, that will be, that is what is expected out of quant. Now how do we do it? And I think this will be applicable. So I want to basically share the uh, the thought process that goes into it, and this thought process will be applicable to all of these use cases that we are going to discuss. So just spending more time on the thought process here for this particular thing, and then maybe we'll extend this thought process application to others as well. Um, so when we talk about models, now we're talking about a quant. Now a quant will be working on this inflation forecasting model. Now you're given a problem, you understand what is an inflation. Okay, inflation is basically an aggregation of multiple commodities, and its change in its price is being recorded, and it's kind of an index, and that is something that we need to forecast. So few things here that one needs to be mindful of. First, we need to do some due diligence or research about the topic in general. So what is inflation? What are the components in inflation? What are the drivers? Because we need to forecast. So we need to identify which are the lead indicators that will help me provide some bit of indication in terms of where the final index would be moving. So there are sub components into CPI inflation, food index, there could be housing index, and so on and so forth. So you need to have some bit of indicators uh, how these will pan out. Um, so first component when we are building a model is a thorough academic research about a particular topic. So academic research would entail knowing the subject in and out. So what we are dealing with and how is that going to impact, or how is that going to be beneficial for the firm. That is first. The second piece of information is what is the data that we can leverage, and what is the source of the data, and what is the frequency of that data that we need to use to forecast this output. Now, frequency is very important here. The CPI inflation number is actually published on a monthly basis. There's a monthly print by RBI, which will provide you that information. Now, if at all you need to only forecast, let's say 1 month, then there is a separate set of inputs that you need to use. If you need to have a larger forecast, larger, I mean, so you need to have a longer horizon forecast, then you need to think about some indicators, inputs, variables which are long term oriented, right? Not only just short term oriented, or maybe the kind of period that you're looking at, those indicators will also be a little bit long term oriented. So um, that's more in terms of the psyche of how you need to think about the horizon as well as the data and the frequency that we're talking about. The third component, so just on the second component, one would also need to understand who are the vendors, how are you going to extract the data. So is it extracted from standard databases, SQL, what it is, and on what basis are you getting that information. um, all of that information is very important, and how good is that data, the quality of the data. So you need to do some pre-processing as well if needed, before that is being applied to the model. And the third piece of information is what is the method that we are going to use for this model, right, for this prediction. So that is also quite important. Now, when we're talking about inflation, one is, let's say, maybe we can talk about, if you're talking about totally statistical tool, then we can do a auto regressive process based model, or an ARIMA model, which is just based on its own price series, and you can just forecast the next one, and that should be it. That is ARIMA. Then, if you're talking about long term, then can we think about some macro level indicators? So let's say GDP growth. There could be equity stock market index as well. So let's say Nifty 50 index. So if there are some variables on which you need to run a regression for the CPI inflation, that can also be a different model. There could be also machine learning based approaches, which are quite prevalent now. One could be recurrent neural networks, which is generally used for inflation forecasting, and that the research says that that has better prediction compared to your ARIMA or AR processes. So there are various techniques in which you will forecast this. That's a model piece. So that's a third component. And then last component, which is very important, is how good are your results? How good are your predictions? So you got the predictions, that is good. What are the metrics on which you can safely say that this prediction is good, bad, or worse, right? So for inflation, and feel free to uh, write in the comments out here in the YouTube channel, what do you think for an inflation forecasting model would be the appropriate metric to assess the forecasting is good or not? Now there could be several, okay, in terms of how you want to deal with this. If your goal is just to understand the direction of forecast, so whether my inflation is going to go up or go down, okay, if that is the thing, it's a binary thing. So binary would need to be assessed in a different fashion. So you need not have a regression based approach. Maybe you can just do, um, you can have other qualitative scorecards to come up with that decision. If your goal is also the magnitude of prediction, and with the degree of confidence in terms of error confidence as well, then you need to have a separate list of inputs, and separate techniques. So these techniques would definitely vary as per your end goal. So that is more important. And depending on the end goal, you need to define your metrics. So if it is just, let's say, just in the previous example, you were saying that whether it's going to go up or down, so it's just going to give you a binary signal, so yes or a no. Or I'm not thinking that maybe same level is, I'm defining it as like down, for example, let's say. And if it is, just for the simplicity's sake, if my CPI inflation is going to go up by more than 10 basis points, I would define it as an up. Everything else will be defined as down. Okay, so if that is the definition on which we are running this forecasting, then a metric would be just doing um, the comparison analysis, wherein we are saying that true positives, false positives, false negatives, and true negatives. We'll just have that um, matrix computed, and we could find out the accuracy of how well our forecasting model is performing. So that's generally a nutshell in terms of how you would want to define a particular problem. So here in the last stage, when we were defining the metrics to assess the outputs, we also touched upon how do you define the output. So what is the variable that you are trying to model out here, right? So that is actually important. So um, that is really important. um, Along with that, we talked about this metrics as well. So these are the broad components in which I would break down any problem that one is dealing with in a quant space. um, Moving on to the next one, which is a statistical quant. Now this is for the retail loan application scorecard building. Now we have home loans, we have car loans, auto loans, and so on and so forth. It could be a manual exercise to really screen through many applicants and take the decision whether a person is eligible to take that loan or not. What if a quant could really work towards building a quick application scorecard? So whenever a customer would want to log in with their own details, let's say the person is applying for a credit card or a home loan, they would enter in all the details, and it is up to us to ask for this detail. So the variables can be defined by us. So let's say if you're talking about a home loan, for example, the income of the applicant, then maybe the loan amount that the person is seeking, the loan, the the purchase value of the particular asset. So a home agreement value would also be required to understand what is the real requirement. So and also there could be other facets as well. So let's say, is a person salaried, is a person salaried or not, as a home, is a person having a co-applicant or not. So there could be other facets in which one would want to capture the data in order to make that decision whether a person needs to be provided a home loan or a car loan or not. Now, how do you define that? Now, how do you define, and this is where, if I were to source these cases on a daily basis, if I am like a credit manager doing providing these approvals, then I would have to work on at least 1,000 applicants every day, which will be kind of a menial task in general. Now, what if I have a kind of a scorecard, or if I kind of have a model which definitely segregates which are my high profile or high net worth customers, or maybe really high value customers who should be definitely be getting loans, and which are my kind of not so well positioned customers, which I need to pay much more due diligence, and I can focus more my attention towards those customers and conduct my due diligence accordingly. If I were to just have work on all the 1,000 applicants, then I'm not really justifying the bandwidth that I'm spending on each of the applicant in a manner that in a manner of riskiness that each of the customer would possess. So this is where this scorecard building would really play that part. Um, Here, it is very simple in terms of first you need to understand what are you trying to define. So you need to basically, my task is to segregate between good customers and bad customers. Now, how do you define bad customers? So bad customers would have different assumptions. So all of these models, as I mentioned, um, would have some assumptions. Now, assumption is just second nature to building any a quant model. So you need to start with some assumptions. Depending on those assumptions, you will build rules, which is a model or a process, right? So here, an assumption for retail loan application scorecard model is going to be something where I'm going to have a history of applicants, which I have sourced so far in the bank, and I am going to see and profile the customers who have not performed well in their loan EMIs. Okay, so let's say a customer who has defaulted in payments, in interest payments, for more than 90 days, which is a 90 days per due, days past due, which is what we call as DPD. I would classify them as bad customers. Okay, and all the rest would be classified as good customers. So I need to identify if a prospective customer is going to be a bad customer or not. So that is the problem statement that I've simplified in terms of helping my credit approval team work with. So whenever the credit approval team will be working on a particular application, they would first see the application scorecard, whether it is a flagged, it is a bad customer from the model or not. If it is, then we need to further due, conduct some more due diligence in terms of why it was done and so on and so forth. So that is just an added flavor, and credit approvers can also spend good amount of time on bad customers than on good customers. So so we are just giving disproportionate amount of time and justifying based on the riskiness of those customers. So in terms of um, so we can use machine learning techniques out here for building these scorecards. We can use regression based approaches to come up with the solution, which finally needs to be also be back tested. So back tested would be in terms of how the model is actually performing. If I were to put it live, um, so you need to have the confusion metrics wherein we are saying that true positive, true negative, false positive, false negative cases. So basically we're saying that whenever we classify a model classifies a customer as bad, it turns out to be good, or a vice versa, right? So then it is a dent on the model. But when consider it to be the opposite, whenever the model says it is a bad, it turns out to be bad, and whenever the model says it to be a good customer, it turns out to be a good customer. That is where the accuracy would really be important. So true negatives, true positives are going to be critical in terms of assessing the accuracy of these kind of models. um, so when we are talking about the binary output, so this is on the retail loan application scorecard model building as a statistical quant. Um, in the interest of time, just moving to the next topics as well, and maybe we can have a deep dives on each of them with some spreadsheets in some future sessions as well. So the next one is market risk quant. Uh, one of the important things for market risk quant is to um, understand what is the potential of loss in a quantifiable fashion in a particular portfolio. Okay, so a value at risk terminology um, is quite industry prevalent in the market, wherein to it helps us to quantify the amount of loss at a confidence level for a particular portfolio, just for monitoring its risk, right? So let's say on a given fine day when the markets are actually not behaving well, or they're actually quite down, what is the level of confidence that I have? What is the maximum, or what is the um, severity of loss that I can experience in my portfolio based on some model? Now, that model can be based on some historical data, which is what we call as historical simulation VAR, value at risk. So, the value at risk has different techniques in which one could build uh, these these calculations, and or it could have some bit of correlations with different variables as well. So that needs to be factored in to compute a value at risk. So portfolio having, let's say, Google stock and an Apple stock and some bonds. So if there is some different kind of correlation among them, like a covariance matrix, then you would get a desired amount of value at risk for that particular portfolio. So these are all calculation metrics, but for that there are inherent assumptions that go into it. So for example, whenever you're doing this value at risk, and let's say you're assuming a historical simulation value at risk calculation, one of the assumptions is your equity returns are going to be normally distributed. So, which means that your prices, equity prices, the holdings of your portfolio would be log normally distributed. So that needs to be tested. Some may have fat-tailed distribution, uh, wherein these assumptions might not hold true, which may be a dent to the calculation that you are generating. So you need to be mindful when you're presenting a model. You need to be mindful of the assumptions that you made, the limitations of the output that is at stake, and a very important thing which you actually covered in the previous session also is the, the level of articulation that you can have in terms of analyzing the output. So let's say you get a var number, you have a calculation. So let's say we talked about that retail loan scorecard model, and you're classifying that customer as bad, for example. You need to know the reasons why you're classifying that as bad, because you can't just say that it's just a model output. You need to actually decompose that particular output in a manner that can be understandable by the decision makers to really value your model. So that is an important skill that one needs to be mindful of as well. Um, so same thing holds true for market risk, value at risk models as well. So you need to understand the limitations of your approach and the interpretability of the same. It is and similar thing is for credit risk quant, wherein let's say we have a good amount of institutional client loans that are at place that a firm might have extended to. At any point in time, we would need to understand. So let's say a firm A has given a loan to, let's say, Reliance, for example. Now, Reliance will so a loan is actually extended so that it is actually repaid back to the firm. Otherwise, if it is not repaid back, then the firm who is actually extending that loan will actually incur a loss. For that to monitor, that is basically what we call it as a credit risk monitoring, and this is just the calculation part of it. There are various other facets in terms of how would you manage that credit risk. It's more about the behavior of the firm, um, then these calculations. So in terms of calculations, if I were to quantify the number that is at risk, there are different aspects that one needs to be mindful of. One is the probability of default. What is the probability of default for that Reliance, in our example, to default, right, on our payment? So maybe you can attribute it based on the financials of the firm, uh, based on recent news that you might have seen, or recent new acquisitions, or maybe some other facets. But can you build a model which is a probability of default model, which would really quantify, maybe let's say there is 10% of chance to default on my payment. Okay, so that 10% needs to be calibrated by some historical data, um, some bit of loss data in the past, or some bit of benchmarking firms data. So let's say Reliance is part of utilities firm, right? So let's say we can have some data points of all the utilities firms and evaluate the the tendency of default over the past several years, and see if the amount that we have actually extended to, what is the risk of losing that. That's just the probability of default. The second piece is loss given default. What if, so even if the default happens, what is the extent of the loss? Okay, so let's say you basically extend $1 million to a particular firm. You might have some collateral when you extend that $1 million. So let's say the collateral is now worth 500,000, for example. Okay, so if in case the person defaults, if in case the client defaults, then at least you can sell off the collateral, which is worth $500,000. So the net loss is only going to be 500,000, which is the 1 million minus 500,000. So uh, and there are various other aspects to loss given default as well. So and that needs to be modeled. So that collateral also needs to be valued on a real time basis. So some may be very less liquid collateral, so you might have to apply some haircut in the pricing that you might be doing on a daily basis when you really think about selling off. So there are various techniques in terms of calculating the loss given default. It's more about how much are you able to recover once there is a default. So these are some important concepts in terms of credit risk computation that one needs to be mindful of. Um, then very last, I think we have these three aspects wherein few of the quant researchers would be um, engaged into some academic study or some new event based research, which is also going to be developing a model. So let's say when we're talking about when will a real estate or a housing crisis begin, when can you have some lead indicators to give you that housing prices are now going to crash, are just going to be on a decline mode. So you need to take some data, um, and is it, and first thing is more important, it's just the output thing that you need to be mindful of. Are you just concerned with respect to um, a 20% price fall in 1 year, or a 50% price fall in like 5 years? So it depends on the kind of slope of the decline that you need, but that needs to be clearly defined in order to work on your model. If you don't have the output or the goal objectively defined, then it will be very difficult to really build a model without it. So and it will be difficult to assess the performance of that model also. So this just helps us stay honest to what we are trying to do. So predicting real estate meltdown, or maybe so some other examples could be, similar examples could be, let's say, will a Brexit happen or not? So can you, with some level of confidence, would you run some quick calculation based on probability theory, or based on some machine learning tools using some data, can you get some inference about this event, whether it is going to happen or when it is happening, or whether it is deteriorating or not. That is something that research quants or quant researchers would be working on. Then comes the series of pricing quants. Um, I'm just taking a pause here. Feel free to. We'll just have Q&A begin in like next 2 minutes. Feel free to line up your questions if you have any, and we can take it up in like 2 minutes from now. Um, so the next is pricing quants. The pricing quants are the ones who would be dealing with providing the valuation of each of these instruments, which is required by the banks um, to manage their assets, right? So a bank would have different kinds of instruments. Some would have like plain equities, which is tradable, observable in the market. So you can it's just like a tradable price. But some may be having some over-the-counter instruments as well. So let's say if there are OTC options or derivatives, then pricing of those options would also involve you to know about stochastic calculus, computational finance basics, and so on and so forth. So dealing with partial differential equation solving and so on and so forth. So one of the important techniques, mostly famous, is the Black-Scholes model for option pricing. So that is quite prevalent for option pricing, and which has good amount of assumptions, but it will help you um, compute the price of an option, of a call option or a put option, given a strike price, given a time to maturity, and so on and so forth. So there are characteristics of an option, and you'll get a final price using the closed form solution of that particular model. The last, but not the least, is the algo trading quants, which would develop some signals in their asset types. So here we are taking currency spot as an example, using technical analysis. So let's say if there is a golden crossover between the moving averages. So let's say if the 50-day moving average of a particular option or of a particular spot price is trading above the 200-day moving average, then it is most definitely a buy signal. So, and then similarly, you could have a sell signal and so on and so forth. So you need to build these in a rule based mechanisms, not just observe them in chart, uh, but have that developed in a model, embed those rules in maybe using Python or Excel, or with some data which is actually going to be fed from SQL or live feed from Bloomberg, whatever that is, to make some real decisions. So if I give out a buy signal, whether it has moved up or not is something that one needs to be evaluating your signals and from a time to time basis. So that is more on the algo trading cons. Um, that's pretty much it on the kind of use cases. Also, few other use cases on the life insurance business is going to be, let's say we want to detect um, a potential frauds when when a particular insurer is claiming for the same. So a person is still alive and still maybe making fraudulent claims. Is there a way to identify or potentially flag whether this claim that the person is making is has a tendency to be a fraudulent claim? So some of the examples could be, let's say maybe the person has just taken the policy issued last in last like 2 weeks, and just after 2 weeks the person is actually claiming for a claiming the same, so as an insurance, right, as a life insurance. So that could be potential thing, and there could be other data points as well, depending on the history of observances of frauds. We can train our model, and then one could basically get the output. um, there could be also liquidity quants as well, who would work on the asset liability modeling for in the banks, for the liquidity risk models. uh, but yeah, I think that's broadly the use cases that I wanted to cover and provide you a gist of. It's more to do with the approach that one needs to follow being a quant, which I want everyone to have as a takeaway from this session, and understand the rigor that one need to follow um, being a quant. So with that, I'll give a pause and see if there are any questions on the presentation or the materials that we have discussed so far. Radhika, you're on mute.
Yeah. Hi Aditya. So first of all, a great session, and really insightful. I think we have some questions. So can we take them one by one?
Sure, sure, sure.
Can you find them on the chat box?
I am unfortunately not able to. Let me just 1 second. Okay, I did not open that chat box. Okay, sorry.
Mhm.
Okay, yeah. Um, okay, so which one do we take here?
Okay, I'll read it out for you. Want to know how can Python be useful
Okay,
and engineer who
okay,
wants
got it.
to
So
finance? Yeah.
right. So okay, I get it. So Aditya Ambler has asking, want to know how can Python be useful? I'm an engineer who wants to pivot into finance. What can I do more to make my profile for quant better other than getting a master's degree? So if you are an engineer moving towards finance, obviously one thing which I can recommend is, obviously master's degree would certainly help, but real life use cases in terms of building models. So I think you'll find plenty of use cases available. Um, if you can develop, um, let's say, for example, some tools that would really help in allocation of your portfolio. Okay, so for that you need to do some reading for sure, but just pick a topic, and just like how I explained during the session as well, it is a methodological, it is a quite a methodological approach, wherein you start with researching on academic papers. So there'll be good amount of papers for that particular problem statement that you find interesting, and then you work on that, you build some code around it because you're already an engineer, you want to pivot into finance, so you basically provide some bit of um, um, some bit of color that you are ready to take that plunge, that you have done enough reading about that particular topic and you are ready to implement that topic, and this is what the implementation look like. Put it in your GitHub repository for others to basically take a look at, and that is how you do repeat and ask for feedback, so from maybe the quant experts. So that's how you would basically um, enhance your personal brand, uh, to move towards more quant based roles from an engineer uh, profile that you have right now.
So I hope Aditya you have your answer. Moving on to the next one. Can cons pivot to portfolio management?
Yes, absolutely. So this is exactly what I would encourage people to work towards. Um, what are quants actually? So quants are folks which are tech savvy, who would really be understanding how to manipulate the data and everything, but also they understand good amount of business knowledge as well, which is related. So here in this topic it is portfolio management. So let's say we're building a portfolio allocation based problem. We are running some optimization, asset class level optimization at our end. So one needs to understand what are the key drivers for that asset allocation, right? So if you have that business knowledge in mind, you can definitely build some tools around it, which can definitely be like a recommender tools when you're taking those investment management decisions, right? So when you are a portfolio manager, you would ideally want to have a suite of tools which would really give me some prompt. Okay, this is the time to buy. Let's rebalance our portfolio. This is the time, and this is how the rebalancing should look like as per the model. And obviously you can have your own overlays as a portfolio manager over and above what your tool would really give to. So I think it's a natural pivot, honestly, if you are um, more focused towards going towards the business side of things. So I think it's definitely possible there.
Awesome. I think we have another question. Is there a pay parity between IITians and non-IITians quants after 2 to 3 years of experience?
That's a good one, actually, and I think I expected this. So I would not like to generalize this, honestly, Ashish. Thanks for asking this question. So I would say definitely IITians are kind of preferred choice when it comes to the quant modeling, or maybe just because from the curriculum or the level of rigor that they go into. Um, so it's just more about the dedication that is expected from an IITian to work on this particular role, and that will naturally be present for most other roles as well. Similar distinction might happen at an entry level for sure, but I would say if you are a non-IITian, if you are a non-IITian, let's prove that you have taken additional. So how do you prove that you are at par or maybe better than an IIT? I don't want to make a comparison, but I'm just trying to give out some ideas in terms of how one could really be at par. Obviously, there is. I can't really qualify it as like a pay parity will be there in all the firms. I can't, maybe not in 3 years, maybe at 5 or 7 years, as we understand more about the business, we stabilize, and after a point in time, your pedigree may not really matter more. It is how efficiently are you able to understand the role, how well are you performing on the role, that is more important, and that is where you need to think differently and understand the perception of the employers. Okay, so if at all you have worked towards that rigor in displaying that, "Okay, I have worked on XYZ myself," as an entry level it might not be expected out of you. So something that you can go beyond, um, I think that would really help. But I would say in terms of pay parity, to a short answer would be, let's say maybe 5 to 7 years. That is a distinct possibility for sure. But I can say at the moment, as I can see, um, the pay parity is not there. When at an entry level, there'll be distinct difference between the pays to start with, and that has to do with the perception of the employers. No particular problems with the candidates, but if you have, so you need to take extra. I'm also not an IITian myself, but I feel after 5 7 years everything is level playing ground. Hope that answers it.
So, Ashish, we hope all your questions are answered. Anybody else can drop in a line if they have any doubts. Meanwhile, awesome. So, Aditya, thanks a lot for the session and also for for taking up all the questions as well. Uh, let's wait for a minute or two if we have any questions. How was your
Sure.
experience with the session?
But it was great. I think I hope, as much as I enjoyed, I think the learners would have also have enjoyed in terms of understanding the details that I wanted to uh, put across. And it's more about the process that one needs to be mindful of if you really are interested in this. So that's the takeaway that I would have the learners have. with the session.
Also, Aditya, I have one question from my side. So, for example, if today I want, so for example, I am a student, and I've just done my bachelor's, and there is no like, I'm yet to, I want to get into quants, but not sure how to do that. So, what is the path, or what are the skills? Like, what is your suggestion? How should I build my career towards it? Because this is one question that a lot of us might, a lot of the learners will also have this question that what is the exact path to getting into quantitative finance?
Yeah, I think thanks for asking, Radhika. So this is something that we discussed in the previous session, but just as um, a refresher. So and it will broadly depend on the kind of background that you start with, right? So if you are a commerce graduate, then essentially you will need to be on top of the programming skills. I've seen people working on, let's say, having a commerce background and quite good in Python coding, right? So may not know, but it will be functional programming. I'm not asking you to be a production developer, IT production developer. So it can be a functional programming way. So if I'm having an idea, can I really code it and uh, make use of it so that it can throw out, it can be an automated fashion. So that is one thing. Let's say I'm taking an example of a commerce graduate, and the second bit, for a commerce graduate, I assume that the person would be quite decent or understanding about the finance basics, that is with respect to understanding different kinds of instruments. um, so that is given. One other aspect is about the math and the stats background. So I'm not sure how much a person would have that bent towards math or science. So if you are really keen to read through difficult academic papers having math equations kind of stuff, or at least have that curiosity, okay, not understanding everything, maybe let's say have some mentor or have um, some senior person who you can reach out to for basically understanding what is happening under the hood. You need not know everything in and out, okay, but if you know, because those math equations will really be important when you are implementing that in an automation fashion. So that is where it's more about the modeling. So modeling will be more objective driven, objectively based. So that's a commerce BTech, BCom graduate, which I was like trying to give you an example. Same thing with respect to a BTech, maybe from a non-IT background, let's say mechanical engineering, for example. Um, so same things would apply here. I would assume engineers would have large, good amount of rigor in the math already, because in their curriculum, compared to the commerce graduates, is what I would generally understand. So the affinity towards math and stats would be decent, and need to brush up there. Also, they would have some bit of programming, cursory programming done in their initial years of engineering as well. So that is something that they can take it to the next level for learning more about Python and functional programming. Still, let's just work on functional programming still, um, and work towards getting in-depth understanding about finance topics. And you not so finance is a very wide in itself, right? So you can focus starting from, let's say, maybe investment management, for example. So or asset management as a business. So how and maybe instruments, for example. What are the kind of instruments that one would need to know, um, not extensively, but if you and then go deeper into it. um, Take stocks and bonds, or maybe some complex instruments if you have to, and then go deeper into it in terms of how the portfolios will be managed, how do you construct a portfolio, and so on and so forth. So that's how you develop understanding, and then it's always on the job learning, which will be required to be successful in this career. Hope that answers.
Yeah, that really answers. I hope that helps others as well. So I think we are done with the questions also. So let's wrap up the session here. Thank you so much, Aditya, for taking out time, especially on a Sunday. Thank you so much, and thank you for everybody who tuned in today to to attend this session and learn more about quantitative finance. We'll try to do more of such sessions. And yeah, thank you so much. So guys, I'm ending the stream now. Hope you enjoyed.
Thank you all. Thank you.